All right, so here we go. Question number 2. So we are in 8.3, looking at question number 2. So you guys have done a bunch of confidence intervals on your calculators. Now we're going to find sample size. Remember, that's what tonight's all about. How do you find the sample size? Look at this question here. You want to obtain a sample to estimate a population proportion. At this point in time, you have no reasonable preliminary estimation for the population proportion. You would like to be 95% confident that your estimate is within 1% of the true population proportion. How large of a sample size is required? All right, so in other words, pretend that we're polling. Remember we talked about this when they want to do like a poll for an election, and they're coming up on election time, and they want to estimate, what percent of the population are going to vote for candidate A. And so they go, all right, we're going to go out and ask people who they're going to vote for. But how many people do we need to talk to? How many people do we need to ask? Well, it depends on how sure you want to be. If you want to be 95% confident and you want to have 1% maximum error, whenever they give sample results, polling results, they always say, our samples show that 52% of the population is going to vote for candidate A, give or take an error of 3%, something like that. So how do you determine that ahead of time? If you're going to do that kind of study, how do you do it ahead of time? You've got to determine in the number in your sample. So let's take a look. How do you do it? Well, I've given you the 3 formulas up there, and let me in fact write them on here for the YouTube situation. So Z equals inverse norm of, what is it? So double parentheses there, right? 1 minus confidence, whatever your confidence interval is. Let me make sure this is clear. Parentheses there. Divided by 2, comma 0, comma 1. And then from there, it depends on what you want. So if you want a proportion and P is unknown, that's our question here. We don't know anything about P. P is unknown. Then the N will be Z squared times 0.25 over E squared. And if you do know something about N, if P is known or estimated, same thing, it's going to be Z squared times P times 1 minus P over E squared. Like that. And then on the other side, there's going to be another formula, which we're going to do in a little bit. Might as well just write it down now. This is if you do a mean instead of a proportion. And I'll remind you what that is in a second. Z times S over E, that's an S there, all squared. And remember, for all these sample ones, we always round up. Always round up. And I mean up. Even like 27.1 will go to 28. Everything goes up because talking to more people always improves your accuracy. All right, let's get back to it. So which one? So first thing you want to decide, first off, you see the N right there, right? So I'm going to help you. The hard thing is always identification. I think it'll be a little easier on this exam than it was in the last one. But you'll see an N there, and you'll go, okay, it's one of those 3 N formulas, which you'll have right on your Exam 3 notes, which I'll crank out for you soon. You'll see that N, and you'll go, okay, it's one of those 3 N formulas. They're asking me for N. How do I know which one? Well, here's a big wall of separation here. I should do like that. That formula goes for both. So, are they talking about a proportion, like a percentage, like 70% of the people are going to vote? Or is it a mean, like what's the average amount of time people are on the internet per day? 1.3 hours. Or, is it some kind of average? Or is it some kind of percentage? Which one is it? Those are the 2 different things we've been doing. Average, 8.1 was all about percentages, and last night's homework, 8.2, was all about means, averages. So which one's this? Are they talking about percentages, or are they talking about averages? Yeah, it says it right there. Population proportion. So yeah, we're talking about percentages. We're talking about one of either this formula or that formula. How do we know which one? Well, is the P unknown, or is the P known? Is the percentage of people that are going to vote for whatever candidate, do they have an idea or do they have no idea? It said right here, you have no Reasonably preliminary estimation. You have no idea. It's fancy talk for you have no idea. So we go, oh, okay, it's this formula. See how we nailed it down? In a minute, they're going to give us ones where we do know something, then it'll be this formula, and then a few minutes later, they'll give us means, and it'll be that formula. All right, so we know the formula. Let's write it down. It's going to be n equals z squared times 0.25 over e squared. And how do we get the z? That's the inverse norm thing, huh? Inverse norm, parenthesis, and then 1 minus confidence divided by 2, comma 0, comma 1. What is the confidence level on this one? 95%, right? 0.95 right there. So you're going to type that into your calculator, hit enter. So start with the z, type that into your calculator, hit enter, get that answer, and then after you have that answer, here's the exact buttons you're going to hit after you've hit enter. So we're going to literally start by typing in exactly this, hit enter, and then follow that with, after that, come on down, just hit the x squared button because that'll square the z, times 0.25 divided by, and what's the error on this one? Within 1%. That's the error amount right there. 0.01 squared. Hit the second power button. You know that second power button on the left side? I think last time I was showing you the up arrow. I realize this is going to be easier for students on the TI is to hit that x squared button on the left. It'll be a little quicker. And then hit enter. And I'll do it too. I wasn't sure if I hit the wrong button there, so I did something a little funny. So yeah, I'm getting 9603.6. So we got to round it to 9604. Is that coming out for you? I noticed also that sometimes I was working with somebody, I can't remember who it was last time, and it wasn't taking the right answer. We tried typing in 9604, and it said no, and then we typed in 9603, and it said yes. So some of the programming, remember this is free software, so some of the programming is, the real answer is 9604. Sometimes they're off by 1. They were on 1. So if it's not taking it, try going 1 higher, 1 lower, and it'll probably be good. Is always the within. That's like how much air you want, how much air tolerance you want on that one. So it's going to be the same formula. Hit enter, and then after enter, hit the x squared button, times 0.25 divided by the error squared. The error is the 7%. 7% squared. Hit enter. Okay, so the confidence on this one's 9. This is 0.99. I'm getting an answer on this one, 338.51, which rounds to 339. So you'd have to interview 339 people to be able to have a 99% confidence that you've got the right answer within a 7% margin of error. So it tells you ahead of time how big your sample needs to be to get the kind of results you want to get. This is how pollsters know how many people they have to include in their sample on that. Okay, so let's try number 4. So number 4, you want to obtain a sample estimate, blah, 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 sounds the same. Here's an N. But notice this time, so this is what you got to pick up on the exam. It says, based on previous evidence, you believe the population proportion is approximately 0.15. So they're giving me a P this time. Notice they're actually giving me a P instead of saying, we have no idea. So notice they're thinking ahead of time, we think that it's going to be about 15%. So remember back over here at our table, it's going to be this category now, isn't it? Because now the P is known, it's estimated at least. And so we use this formula, which is almost the same, but instead of the 0.25, we have P and 1 minus P in parentheses. So let's do that. All right, so here we go. It's going to be, the N will be Z squared times P times 1 minus P over E squared. Let's start with the Z like usual. Z is still the same thing. Bless you. Inverse norm. And the double parentheses, 1 minus the confidence level, divided by 2, 0, 1. And the confidence level, at least on mine, is 0.99. So bring down the 0.99. And then hit enter. And then once you got that, hit the x squared button. And then parenthesis P, parenthesis 1 minus P. And P in this case is 0.15. Like that. Divided by, and then E, which is, how do you know what the E is? What words key you in on the E? Have you noticed the words they're using all the time? Within. Within. See that? Within 1.5. That's, and I'll put that on your exam 3 notes. I'll say air within amount. Because they almost always use that word within. Because they're wanting to get an answer that's within a certain amount of air. So that's their air number. So you always have to change that to a decimal, right? Air is 1.5%. So we want to get an answer that's within an air amount of 1.5%. So change that to a decimal point. Oh, it moves back 2 places, right? 0.015. Got to square it. Don't forget to square it right at the end, like usual. And then hit our final enter. 3066.7, which rounds to 3067. They would need to talk to 3,067 people to get the kind of accuracy they want. All right, let's try number 6. Are we ready to move forward? Look at number 6. What words in there? Let's pretend it's exam time. You're just trying to distinguish which one's the right formula up there. So what words do they use? That little 4-letter word is jumping off the page for you. Yeah, this one's not a proportion. It's a mean, which is nice. We only have one formula for mean. You don't have to worry about known and unknown and all that stuff. We have, the 2 formulas for the proportion, but just the one formula for mean. So as soon as you see an N down here and a mean right there, you go, I know what I'm doing. I know which formula to use. It's N equals Z times S over E whole thing squared. Now, how do you do whole thing squared? See how this one has whole thing squared rather than just the E squared at the bottom or the Z squared at the front? So just, you could do the whole parentheses, but I found that's confusing and hard for students. Instead, just at the very end, hit enter and then square afterwards. And it'll make sure it squares the whole thing. I'll show you. So here we go. We start with the Z, just like always, nothing new there. It's inverse norm. Double parenthesis, 1 minus confidence, divided by 2, 0, 1. And what is the confidence level? Oh, 95, so put that in as 0.95 right there. That's good. So type that in and hit enter when you're done. And then after you get that, we'll come over to here. Come on over to here. And then go, don't go squared, go times the S, the standard deviation. That's the sigma, right? That's the Greek S, same as the English S. Doesn't matter. 66.4. The Greek just means it's the true for the whole population. Whatever, we don't care. Divided by E, that's the within, right? Air is always within. Within 1. So we don't have to worry about decimals or anything here. Just divided by 1. Then hit enter. Because whenever you hit enter, you signal the calculator to compute everything up to that point and get a final answer, and then you hit the x squared afterwards and enter one more time, because then it will have squared everything. That way you don't have to worry about all the parentheses and stuff. That's the easier way to do that. Yeah, I don't remember getting an answer that big before. 16,936.8. You got to round that up then. 16,937. The same thing? 7. So, see if you can figure out which kind this is. All right, so this is a mean. How do you know they're talking about mean? Well, they talk right here. They say the word average right there. Yeah. So, and there's no percentages anywhere except the confidence level, which is always there. So it must be a mean. So n equals z times s over e all squared. So that means we start with the z. Z is inverse norm, double parentheses, 1 minus confidence divided by 2, comma 0, comma 1. Hit enter. And then, from there, we go times s. The s is the sigma, the standard deviation, the Greek s, 80.6. Divided by the error, the within, there it is, within $3. So they want to figure out the average amount parents spend on their kids' birthday parties, and they want to average it, they want to get the estimate within $3. So if kids spend $100 on average, they want to be right on within $3 error amount. So that's the error amount, the 3. Remember to hit enter, and then hit the second power and enter one more time. That way you make sure the whole thing was squared. Is everybody seeing that? That's how we're doing the whole thing squared rather than just the z squared or just the e squared. The whole thing, because that enter says now compute the whole thing, calculator, and then square that whole thing and give me the answer. So when you do all that, so I'm getting 1952.9, which is 1953 rounded up. We good? You know, it's unfortunate. All mine came out to be decimals that would round up anyway. I was trying to make the point. It's very unfortunate. My particular examples all came out more than 0.5. Remember, you round up even if it was 0.1. Always round up. Because talking to more people in your sample always improves accuracy, doesn't it? That's why we always round up for more accuracy. 1953 people.